This carbon and its compound has got some points here. First point is introduction. Second, bonding in carbon, the covalent bond. Then we will see electronic configuration of carbon. Then we will see the covalent bond, allotropes of carbon. Then versatile nature of carbon. We will see what is catenation, what is Tetra valency, and next we will see saturated and unsaturated carbon compounds. Then chain, branches and rings in carbon compound, structural isomers, cyclic carbon compounds, those are in rings, hydrocarbons. Then we will answer about the something called as will you be my friend. Then homologous series we will understand. After that we will see how to name them, that is nomenclature. Then chemical properties of carbon compounds, that is combustion, oxidation, addition reaction and catalysis. All these things we will see in this chapter. The first part is introduction. Everything we see in the world is carbon compound or carbon based. The foods that we intake, then clothes that we wear, medicine, books, living structures, etc. all are carbon based. And carbon is present in Earth's crust, first one, and also in the atmosphere. In the Earth's crust, it is in the form of carbonates, hydrogen carbonates, coal and petroleum, which is about 0.02%. And in the atmosphere, in the form of carbon dioxide, it is 0.03%. So with this introduction, we will see the properties of ionic compounds. Bonding with carbon and covalent bonds. How does the bonding happens in carbon and formation of covalent bond? First, we will see the ionic compounds, the properties of ionic compounds. They have got high melting point and high boiling point. They conduct electricity in solution and in molten state. Then what are the properties of carbon compounds? Most carbon compounds are poor conductor of electricity. Force of attraction between the molecules of carbon compounds are not strong. And when they are not strong, therefore the bonds are not strong. In carbon compounds, bonds are not strong. These are some of the examples. So if I complete the topic today, the problems or the question solving will be there tomorrow. So examples of carbon compounds with melting point and boiling point are given here. Acetic acid, chloroform, ethanol, methane. And these compounds with formulas you have to remember. Acetic acid is CH2COOH, that we will see later also. Then chloroform is CHCl2, ethanol is CH3CH2OH, and methane is CH4. And these are their respective melting points and their respective boiling points. So we have seen the properties of carbon compounds and ionic compounds. Next, we will see electronic configuration of carbon. What is the atomic number of carbon? It is 6. And the valence electrons are 4. You see, this is the nucleus, 2 electrons in the first shell and remaining 4 electrons in the second shell. Second shell should have been 8 electrons in order to completely fill the second shell. But only 4 are available. So in the outermost shell, there are 4 electrons. So this is the electronic configuration of carbon, which you already know. So with this electronic configuration, the 2 conditions are required to attain completely filled electrons. In order that it becomes a stable one, it needs to fill all 8 electrons in the outermost shell. And this can happen in two ways. One way is gain 4 electrons or lose 4 electrons. Either of these. It can gain 4 electrons or lose 4 electrons. But there are difficulties in happening both these things. What are the difficulties? If they gain 4 electrons, total electron will become 10. And electrons are negatively charged particles or negatively charged, and then protons are only 6, which are positively charged. So what will happen is electrons become more, which will become very difficult for the nucleus to hold them. And it is very difficult to lose 4 electrons because it requires large amount of energy to lose these electrons. So these are the problem. The problem is that it is difficult to hold 10 electrons. And here the problem is that it requires large energy to lose electrons. So then what is the solution? Solution is carbon will have to share 4 electrons with other carbon atoms or atoms of other elements. That is the solution. For example, let us see. It can form single bond with hydrogen. Because hydrogen is with atomic number 1, so valence electrons are 1. So hydrogen, when it combines, you get H2. So this is H2 molecule because 1 electron from each hydrogen is shared and a single bond is formed by sharing of electron. Then we will understand formation of double bond, that is with oxygen. Oxygen is having atomic number 8, so valence electrons are 6 because 2 are in the first shell, remaining 6 will be in the second shell. What will happen in getting the bondings is, you see here, 1, 2, 3, 4 electrons of these are there here, and 1, 2, 3, 4 are there. So 2 more are there. So 2 electrons will go over here for sharing, and 2 from here will go for sharing. So instead of 1 pair of X, we are having 2 pair of X. So the double bonding. So oxygen has got double bonding. Then how to form the triple bond? For that example is nitrogen. Nitrogen is having atomic number 5. So the valence electron, that is 2 goes in the first shell, remaining 5 goes in the second shell, which is a valence shell. There each has got 5. So out of that 5, 2 remains here, 3 goes for sharing, and also 3 from here goes for sharing here. So there are 3 pair of X. So the nitrogen forms a bond which is called a triple bond. Now let us come with the methane. Hydrogen has got 1 valence electron, so it is ready to share 1 electron. Methane has got 4 electrons, so it is ready to share 4 electrons. At the center is a carbon having the 4 valence electrons, so it will share 1 electron, that is X over here. It is X stand for electron from the carbon. And there are 4 hydrogen, each of which share 1 electron. So this hydrogen shares 1 electron, which is shown in the dot, this one, and this one. And this structure is called as electron dot structure. Sometimes you will be asked to draw electron dot structure. Then you will have to draw this diagram where electron sharing by carbon are denoted by X, and hydrogen sharing each electron is denoted by dot. So this is electron dot structure of the methane, because you see 4 electrons each from one hydrogen are shared with the each electron of carbon, and so there are 4 bonds formed, separate bond. At the center is the carbon, and with each bond is connected with the hydrogen. This is the structure of methane. So if you are asked to draw the structure of methane, then you draw this. If you are asked to draw the electron dot structure of methane, you have to draw this. I hope this is clear to you. What we have discussed here is the carbon as having 4 valence electrons, and it is very difficult to form the bond because of these 2 reasons. So the solution is share the electrons with the other carbon atoms or atoms of other elements. So these are at other elements. These are also other elements. These are also other elements, and these are carbon with the other element, for example, the hydrogen. Then next is the covalent bond. Bond formed by sharing an electron between 2 atoms is called as the covalent bond. So here these and these are the covalent bonds. These are also covalent bonds. So covalent bond is nothing but bond formed by sharing an electron between 2 atoms is called covalent bond. And covalent bonds are strong within the molecule, but intermolecular forces are small. So between the other molecules, they are loosely attached, and that is why they have poor melting point and boiling point. Now, carbon compounds, one is having the carbon compound, and the compounds formed by carbon compound, they have got strong forces within the covalent bond, but poor intermolecular force. And that is why their melting point and the boiling point are poor. Also, you have to understand this. They are poor conductor of electricity. And this is because their electrons are already shared and not available for conduction. A question can be why carbon compounds or the covalent bond compounds are poor conductor of electricity. That is because their electrons are already shared and that they are not available for conduction. That is the reason. And then we will see allotropes of carbon. Now, elements of carbon occurring in different forms, widely varying physical properties are called allotropes of carbon. So they are having widely varying physical properties. Now, here I will show you there are 3 allotropes. One is called as diamond, another one is called as graphite, and the third one is called as Buckminster fullerensis. That is written as C60. So each one of them I will discuss with the structure, property, and structural diagram. First thing is structure. Each carbon atom bonds to form 3-dimensional structure. You see, this is a 3-dimensional structure which is formed. Then graphite is carbon atom is bound within 3 nearby carbon atoms to give hexagonal array. So you see, these are hexagonal array. And the third one is C60 are shaped like a football. You see, the structure is shaped like a football. Then what are the properties? Physical properties are different, but the chemical properties are same. That is why They are called as allotropes. They are hardest, not good conductor of electricity, and they are synthesized by pure carbon to high pressure and temperature. So these are the properties you have to remember. Regarding the properties of graphite, physical properties are different, but again they are having the same chemical properties. They are smooth, slippery, and good conductor of electricity. Here this was not good conductor of electricity, but graphite is good conductor of electricity. So you should know these properties, and structure we have already discussed. Then we will see versatile nature of carbon. Why versatile nature of carbon? For the simple reason, there are large number of carbon compounds, and the carbon compounds known are 3 millions. 3 million means 30 lakhs carbon compounds are known, and many more are there which are not known, and that is why it has got versatile nature of carbon, because carbon compounds are large in number. So large number carbon compounds are there. Then next question is, why there are large number of carbon compounds? This is a question, and you may be asked this question. This is because of the two factors. One factor is called as catenation property. Another is the tetravalency, and tetravalency is nothing but 4 valence electrons are there. That's why it is called as tetravalency. Valence electrons are 4. Tetra meaning 4 and valency meaning valence electron. And that is why there are large number of carbon compounds because of these two things, catenation and tetravalency. So we will see each of these factor, what is catenation and what is tetravalency. The first thing is catenation. What is catenation? Catenation is unique ability of carbon to form the bond with the other atoms of carbon, giving rise to large number of molecules called catenation. Catenation is nothing but of its property to form bond with the other carbon atoms. So what are the types of compounds available with the help of catenation? One is called the long chain, another one is called the branch chain. The third one is called as cyclic, that is carbon atoms arranged in rings, that we will see later on. Here you have to just know that types of carbon compounds are long chain, branch chain, cyclic, that is arranged in the rings, and carbon atoms to a single, double and triple bond. Accordingly, we have got different types. So the 3 types are there here. One is single bond carbon atoms, another one is double bond carbon atoms, another one is triple bond carbon atoms. Apart from these 3, we can categorize them in these 3 types, that is having single bond, double bond and triple bond. And then again, as per the number of bonds, we have got some more categories. One is saturated compound, another one is unsaturated compound. The compounds with one or a single bond are called saturated compounds, and compounds with double or triple bond is called as unsaturated carbon compound. Then next, out of these 2 factors, one catenation I have discussed now. Let us discuss what is tetravalency. And as I have told you, tetravalency is nothing but carbon is having 4 valence electrons. That is why it is called as tetravalency. So, and therefore, it is capable of bonding with 4 atoms of other compounds or atoms of oxygen, hydrogen, nitrogen, sulfur, chlorine, and other elements. So, because of tetravalency, so many things are possible. So now let me go to so far we have discussed about the first part, sorry, third part we had started. Now let us discuss about 3.1. In 3.1, we will discuss about saturated and unsaturated carbon compounds. We have seen saturated are with single compound and saturated with single compound and unsaturated are with double and triple compound. I will take example one, which is methane. Methane is C2H6. C2H6 is methane. And how to form the electron dot structure and structure of methane, that we will see. There are two steps. First, there are how many carbons are there? Two carbons are there. So you join two carbon first. So that will become carbon-carbon. And to each carbon, you fill the remaining bond with the hydrogen. So with this C, there will be 3 hydrogen. With this C, there will be 3 hydrogen, and the fourth bond is between the 2 carbon. So this becomes the structure. And for electron dot structure, what you have to do is take 2 carbon, and how many hydrogen are there? 1, 2, 3, 4, 5, 6. Here there are 6 hydrogen. So it is 3 hydrogen to 1 carbon, 3 hydrogen to another carbon. So it will become 6. And each hydrogen will share 1 electron, which is represented by dot in every one. So dot represents electron sharing by hydrogen. And cross, this is dot, another one is cross, electron sharing by the carbon. And this is electron dot structure. I hope you will be able to draw the electron dot structure. Please practice sometime drawing this electron dot structure, because while looking at it, you feel like I can. And now C2H4 is ethene. So here there are 3 steps, 2 carbons. So I form carbon-carbon bond. Then there are 4 hydrogen, 2 hydrogen to this carbon and 2 hydrogen for this. It will become 4. But does each carbon has got 4 bonding? No. 1, 2, 3 here, 1, 2, 3 here. In order to make 4 bonding, I put another bond. So there is a double bond over here. This double bond and these 2 bonds will form the 4 bonds for each electron. And this is electron dot structure. And because of the 2 bonds, double bond, here there are 2 pair of the electrons. Those are shared over here. So now we have seen here the unsaturated one, how to write the structure and electron dot structure. Then we have seen the unsaturated one, how to write the structure and electronic dot structure for double bond. Similarly, you can take the example of ethane. Ethane is a triple bond one. So here next is 3.2, chain, branches and rings. How to obtain chain, branches and rings? So for that, saturated compounds are alkanes. I was telling you about chain, branches and rings. Let us understand these chain, branches and rings. First is the saturated compounds. And saturated compounds are called as alkanes. We have got saturated compound, which are called as alkanes, and another one as unsaturated compounds. Those are 2 types. one is alkene, E and E at the last here. Here at the last is A and A, here at the last is E and E. And the next type is alkyne, Y and E. So this is single bond, this is double bond, and this is triple bond. So here the formula, general formula for alkane is CnH2n plus 2. This is the formula for alkane. So it is CnH2n plus 2. For alkene, it is CnH2n. And for alkyne, it is CnH2n minus 2. For alkane, general formula is this CnH2n plus 2. Here 2 is reduced from the hydrogen. So for alkene, it is CnH2n, and for alkyne, it is CnH2n minus 2. So let me go ahead. So there are different things. I hope, I think you may not able to see this, so I'm writing it here. This is methane. Methane is CH4. If you see the formula, it is C1, and double if you make, it will be 2, and add 2, it will become 4. So it is C with 4 hydrogen, you can see here. Then is ethane. Ethane is C2H6. So make the twice of 2 will become 4. 4 plus 2 will become 6. And this is the structure. Then we have got propane. Propane is C3H8. Double of 3 is 6 plus 2 will be 8. And this is the structure. Then butane. Butane is having 4 carbon atoms, and this will be H10. So 4 into 2 is 8, and plus 10, plus 2 is 10. So this is the structure of the butane. Then we have got pentane. Pentane is having 5 carbon atoms, and 5 to the 10 plus 2 will be 12 hydrogen over here. Similarly, hexane is C6, 6 to the 12 plus 2 will be 14. So this will be H14. And now you should able to write the formula from the name, or from formula you should able to understand the name. And similarly, you can write the formula for alkene and alkyne. Let me take these names in case of it is a double bond. This will be methane, ethene, propene, butene, pentene, and hexene. If we take the triple bond, that is alkyne, this will not have anything. This will be ethine, then propine, butane, pentane, and hexane. So with this nomenclature understanding, further nomenclature is also there in more detail that we will see. What are structural isomers? You see here, butane is there, C4H6. If I write their structure in 2 steps, 4 carbons are there, so I will write in a straight form and attach hydrogen to them. This is one structure. Or I can do it like this. 2 carbons like this and 2 carbon with branching. This is without branching, this is with branching. and then attach hydrogen to each one of them. But this becomes a different structure. This becomes a different structure. This is called as the straight structure. This is called as the branch structure. So that is why they are called as structural isomers. Compounds of carbon with identical molecular formula. See, molecular formula is same. That is C4H10. Yeah, C4H10 is the formula, but the structure is different. Molecular formula is same and structure is different. Then such compounds are called as structural isomers. So you may be asked a question to state what is structural isomers, and or you may be given the two structures and identify whether they are structural isomers or not. After that is cyclic carbon compounds. For example, chlorohexane and chlorohexane are C6H12. So 6 to the 12. In chlorohexane, it's just a double one. So in chlorohexane, these are cyclic carbon compounds. It forms a ring of carbon, and then you attach 2 hydrogen to each one of them. You will get chlorohexane structure. So this is chlorohexane. Then we should know the structure of benzene. Again, it is cyclic. In benzene, we have got C6H6. The hydrogen are 6. Here, hydrogen were 12. So for each carbon, they were attached 2 hydrogen. But here, ring is there, but each carbon is getting 1 hydrogen shared. And with that, it doesn't become the 4 bonds. For example, to have the 4 bonds, there are bonds here, 2 bonds here. So this carbon has got 1, 2, 3, 4 bonds. Like that, if you see for each carbon atom, there will be 4 carbon atoms by just putting the double bonding. So benzene, because double bonding are there or double bonds are there, it is ENE, that is alkene. So alkene, ENE, that is why it is ENE at the last, benzene, because 2 bonds are there. Then hydrocarbons. Carbon compound which contains carbon and hydrogen are called as hydrocarbons, which you already know. Types of hydrocarbons are 1 alkane, 2nd alkene, 3rd one are alkynes. The first one is saturated with single bond, unsaturated with double hydrogen, double bond, and the 3rd one is unsaturated with triple bond. Now, this part is very important in for nomenclature, for writing the names. A topic here is, will you be a friend? A carbon also forms bond with halogens. What are halogens? Chlorine, bromine, iodine. These are called as halogens. Then with oxygen, nitrogen, sulfur, by replacing 1 or more hydrogen from the hydrocarbons. Now we have seen all with the hydrocarbons. So hydrogen is removed and replaced with the new thing. And what are those new things? New things are chlorine, bromine, iodine, oxygen, nitrogen, sulfur. Anything can be replaced. And that what it is replaced, it's called as heteroatom. The element which replaces hydrogen in hydrocarbon is called as heteroatom. And heteroatom is also called as functional group. So now this is the table where heteroatoms are there and class of compounds and formula of functional group. When chlorine bromine is there or halogens are there, we call as halo. And we start the name of compound with chlorobromoalkane. And the formula is, instead of EH, there will be Cl. Instead of EH, there can be Br, that is bromine. Then with oxygen, there can be alcohol, aldehyde, ketone, or carboxylic acid. For alcohol, hydrogen is removed and replaced by OH. For aldehyde, hydrogen is removed and replaced by COOH. Ketone is replaced by COO, and carboxylic acid is replaced by COOH. So when there is COOH, it is called as carboxylic acid. And we will see the names in the next topic. And we will see these names, nomenclature, and then stop, because the fourth topic or the last topic we will cover in the next class. So that will be only one page, and then solve the problems in the next class. Now very important thing you have to remember, that is called as homologous series. So chemical properties of compounds, some compounds are very much similar. Such series compounds in which functional groups substitute the hydrogen in the chain is called as homologous series. Let's see what are the homologous series. The first thing, methane, ethane, propane, and butane. If we take this example, and if you replace one hydrogen by one OH, then it will become CH3OH, that is called as methanol. See, when alcohol is there, OH is the alcohol. Last word you add OL. So methane will become methanol. Then ethane. Ethane is C2H6. Then you keep C2H5 and one H you remove and put OH. This will become ethanol. Similarly, propane will become propanol. C2H8OH. Then butane will become butanol. Then let's see a homologous series of alkenes. CH4, C2H6, or in general formula, it is CnH2 plus N, which I had already told you. So the difference in CH4 and C2H6 is CH2 units. Difference between C2H6 and C3H8 is CH2 unit. So you see the same difference is there. Now if you take alkene, the difference is again CH2, and the general formula is CnH2n. It is CnH2n. This is CnH2n plus 2. Then homologous series of alkyne. Again, the difference is CH2 and the general formula is CnH2n minus 2. And the last in this class, we will see about the nomenclature. Now the first is haloalkane. So prefix you can write as chloro, bromo, and anything. So here one hydrogen is replaced by one chlorine. So this is called as chloropropane. There are 3 carbon, so it is propane, chloropropane. The next one, this is bromine, and again this is propane, So it is bromopropane, and this is chloropropane. Similarly, you can have chloromethane, chloroethane, chlorobutane, and so on. Now, next one is alcohol. 3 carbons are there, so it is ethane. Sorry, propane. 3 carbons are there, that means it is propane. And OH is there, so I can write this as propanol. Similarly, in the third case, we are having aldehydes. So here with C double bond O, and last is Al. So this can be named as propanol. This is propanol, and for ketone, it is ONE. So 3 carbons, I will write this as propanon, ONE, propanon. Similarly, when carboxylic acid is there, COOH, here last one is COOH. So this is called propanoic acid, OIC acid, propanoic acid, butanoic acid, methanoic acid, and so on. The next one is alkene. So here there is a double bond, so it is called as propene. 3 carbons is propane, and double bond is that's why it is propene. And again 3 carbons and triple bond is there, then it is called as propyne, YNE at the last. And this is how you can name anything that is given. So I have used example with 3 carbons, so it is propane. You can write these formulas for 2 carbons, that is for ethane, for 1 carbon, that is for methane, for 4 carbons, 5 carbons, and so on. And accordingly, the names will get changed. The chemical properties are divided into 4, not 4. So first one is combustion, the second one is oxidation, third one is addition reaction. So they are divided into 3 categories. So most fuels are either carbon or its compounds. So can you tell me the fuels which are carbon or its compound? All petroleum products, all gases which are used for burning. Let's say carbon, the fossil fuel, petrol, diesel, kerosene, all these are carbon and its compound. Coal is itself is a carbon and others are its compound. So most of the fuels are either carbon or its compound. We will see these reactions one by one. The first one is combustion reaction. Most carbon compounds will burn in oxygen and will release carbon dioxide. That is why by burning fossil fuels, we get harmful products like carbon dioxide along with large amount of heat and light. So actually the main product it gives by burning the carbon and its compound, you get large amount of heat and light, which we use. This is oxidation reaction. So combustion takes place with the help of an oxidation reaction. So carbon with oxygen. See, the first reaction is carbon with oxygen. Will give you carbon dioxide plus heat and light. So please remember this chemical equation. C plus O2 is equal to COT plus heat and light. Then this was regarding the carbon, that is coal. Second one is methane gas. CH4 is methane gas. When you burn it with the help of oxygen or in oxygen 2O2, you will get carbon dioxide plus 2 water molecules plus heat and light. The second equation that you have to remember. What is this CH3CH2OH? Can you tell me? Because we have so far now learned the nomenclature. CH3, CH2, OH. How many carbons are there?
2.
When 2 carbons are there, actually it should be C2H6. What is C2H6? Is it methane or ethane?
Ethane.
Ethane, right. It is ethane. So please do remember all this. Methane, ethane. See, I'll show you again here. You have to remember all this. Methane, ethane, propane, butane, pentane, and hexane. So if you remember these names and their formulas, then it will help you. So likewise here, I have taken the example of CH3CH2OH. This C2H6 is methane. From there, one is removed, one hydrogen is removed, C2H5. See, CH3 plus H2 will become H5. And one hydrogen that is removed is replaced by OH. And what is OH? OH is functional group called alcohol. OH is functional group called alcohol. And so what is the name of this? Because of ethane and OH, this is called ethanol. This is called ethanol. There we have taken the example of butanol. That is C3H7OH is butanol. I hope you know how to remember the names of this. Because 2 carbons are there, it is ethane, and one hydrogen replaced by OH, which is a functional group of alcohol. So you write it as, instead of ethane, you write it as ethanol. Last word is OH. So this is ethanol with 3 oxygen. Do you remember alcohol? When you burn it, it will burn or not? Alcohol is, when comes in contact with the flame, it will get burned. So alcohol with 3 oxygen, you will get 2 carbon dioxide plus 3 water plus heat and light. In all these things, common output is heat and light. Because we are using this, most of these carbon compounds for getting heat and light. And another common thing is they are reacting with oxygen. Third common thing is that it is giving carbon dioxide. So this is called the oxidation reaction. When it burns in the presence of oxygen, giving out carbon dioxide and heat and light, it is the oxidation reaction. Okay. With this, let me go to the next one. Burning of saturated hydrocarbons versus burning of unsaturated hydrocarbons. So difference between these two is normally asked in the examination. So first, about the saturated hydrocarbons which are having single bond, normally gives clean flame. So saturated hydrocarbons gives clean flame, whereas unsaturated hydrocarbon burns with yellow flame. It gives smoke in limited oxygen. If the oxygen is less, then it gives smoke. Otherwise, it doesn't give us smoke. Methane gas, which we burn at home, does not give any smoke. But if you burn it in the limited air, limited oxygen, you will get a little smoke. Whereas if you burn unsaturated hydrocarbons, you will get lot of smoke. This is the difference. So difference between saturated and unsaturated, that unsaturated burns with clean flame, unsaturated burns with yellow flame. Saturated does not give any amount of smoke, but limited smoke. In the case of oxygen is limited. Here it gives lot of smoke. Then gas stove, you must have seen. In the gas stove there is inlets for air. Those inlets you see for taking in the oxygen or the air. If oxygen is taken in, then it will burn with smoke free. So this is the difference you will have to cite. You will be asked to differentiate between saturated and unsaturated carbon compounds with respect to the flame or with respect to the burning. So you have to give this point of difference. Then utensil gets blackened and fuel gets wasted if air is blocked. In the case of saturated hydrocarbons, if the air is blocked, then utensil will become blackened and the more fuel will be wasted. So these are the differences that you should know in connection with the burning. Then it gives out pollutants. What are the pollutants? Coal and petroleum has got nitrogen in it and also sulfur in it. And this nitrogen and sulfur with oxygen gives out oxygen of oxide of nitrogen and sulfur of oxide of sulfur. And these oxide of nitrogen and oxide of sulfur, they are major pollutants. So because of the burning of coal and petroleum, we get major pollutants which are oxides of nitrogen and sulfur. This was regarding the pollutants. And next we will see oxidation reaction. Carbon compounds easily gets oxidized on combustion. Alcohols are converted into carboxylic acid using oxidizing agent, and this reaction is normally asked. So either you may be asked to state which is the oxidizing agent and so on. So for example, this CH3CH2OS is what? What is the name of this? CH3CH2OH? Yes, now we are ethanol. This ethanol, when heated using alkaline KMNO4, potassium magnet oxide, or with acidified C2Cr2O7 plus heat, you get what is called as CH3COOH. And here CH3 or CH4 is methane. So, and COOH is acid. So this is methanoic acid, and another name is acetic acid. So CH3COOH is acetic acid or methanoic acid. So this oxidation reaction and oxidizing agent, that is KMNO4 or K2Cr2O3, these are the oxidizing agents. You have to remember the name of this. And ethanol is converted into acetic acid. This chemical reaction we should know by heart. And the last one is addition reaction. In addition reaction, what happens here, you see here, if you have got unsaturated hydrocarbon, for example, this is unsaturated hydrocarbon because there is a double bond. And unsaturated carbon hydrocarbon gives rise to saturated hydrocarbons in the presence of catalyst. What is the catalyst used here? Catalyst used here is a nickel. In the presence of hydrogen and nickel catalyst, this unsaturated hydrocarbons get converted into saturated hydrocarbons. So this is unsaturated, and this becomes saturated because there are no double bond, all are single bond. So here R and R, 4R are kept as it is, and two hydrogens gets attached to this, and so it becomes saturated hydrocarbons, and this was unsaturated hydrocarbon. So this addition reaction you should remember. And where is this addition reaction is used? This question is asked every time mostly. Use is in hydrogenation of vegetable oil using nickel catalyst. This is the use. And you must be knowing what is catalyst. Catalyst is a substance which causes reaction to occur and make it faster without taking part in the reaction. So this is regarding the catalyst. So this is all about this chapter carbon and its compound.
We at eLearning Career Academy are running classes for standard 9 and 10 in maths and science, and also for standard 11th and 12th in physics, chemistry, mathematics and biology in offline as well as online mode using memory techniques. Here are the links for joining these classes. These links are also given in the description of this video.